Hey guys, these are your notes on the Electron Shuffle. The Electron Shuffle is just about what goes on the inside of the wires on a circuit, right? What's going on with those electrons that they travel around the wires in a circuit, right? So let's start. The Electron Shuffle, what it is it's a model of how the internal framework of a circuit acts. What are those electrons doing in a circuit? All right. You got a couple parts of a circuit, symbols you should know for our diagrams. The battery, little knob on the end, light bulb, pretty self-explanatory. Electrons are going to be represented by stick figures. One stick figure is one electron. And last thing, energy. Here's my bad diagram of a pretzel. You know, you need pretzels to eat, you need energy, so they're going to represent energy in our notes and in our activity we do after the notes. And 1 joule, that's the unit of energy, 1 joule of energy is represented by 1 pretzel, right? So here's a diagram on the left of what the shuffle looks like. And as you can see, electrons, they walk around the circuit, right? And they're going to the right on top, on bottom, right here, they're going to the left. So take a second to draw this diagram for yourself, right? And then I'll explain it. You can hit pause if you want. Okay, so electrons, they pick up energy at the battery, all right? So the battery, basically what it does, it passes out pretzels, which represent energy. The battery is where all the energy of a circuit is stored. So when electrons get to the battery, that's where the whole process starts. Here they pick up energy right there. And then they're holding the pretzels as they walk to the right. They're holding that energy. As you can see, each of them has a pretzel in their hand. So you should all draw them as holding energy right there. And where are they carrying that energy that they picked up at the battery? They're carrying it around to the light bulb. So the light bulb is where they deposit their energy. And what does that energy come out as in a light bulb? It comes out as light energy, right? So once again, energy is picked up at the battery. They walk with the energy in their hands over to the light bulb where they deposit the energy. And you know, the light bulb could be anything, be your refrigerator. Notice at the bottom, they're no longer holding pretzels. Why? Because they put them inside of the light bulb. And those pretzels, you know, which represent energy, got shined out as light. So they're no longer holding pretzels. But where are they going without energy in their hands? They're going back to the battery. So the electron shuffle, it's a process that repeats itself. They pick up energy at the battery, drop it off at the light bulb, go back to the battery, and pick it up again until the battery doesn't work anymore, until you got to recharge it or throw it out. Okay, so you know, light bulb uses pretzels, battery passes them out. Okay, here's 2 definitions you need to know about a circuit: voltage and current. Voltage is measured in volts, represented by the letter V. Current is measured in amps, represented by the letter I. I guess C got taken somewhere else, so I represents current. Voltage is the amount of joules, that is energy, the amount of pretzels, basically. You can write that down. Remember, 1 pretzel was 1 joule of energy. The amount of those that are held by each electron. And under voltage, why don't you draw yourself a little diagram here. Before you even write down current, before you even write that down, just draw yourself this little diagram under voltage. There you go. Okay, so 1 volt is when the electron holds 1 joule of energy. Now, what would be 2 volts if our electron held 2 joules of energy? or 2 pretzels, then they would have picked that up at a 2-volt battery, right? And what would 3 volts be? That'd be if each electron held, each one, would hold 3. So all those electrons in your circuit would each be carrying 3 pretzels. That would be 3 volts. So voltage is just a measurement of how much energy each electron carries. How much energy each electron carries. So a 9-volt battery, what that does is it passes out 9 pretzels or 9 joules to each electron. That's what a 9-volt battery does. Passes out 9 pretzels or joules to each electron. Coming out of our sockets is 120 volts. Wow, so that means each electron going into anything you plug into the wall. How much pretzels is each electron carrying? 120 pretzels. 120 joules. That's a lot, and that's why you get shocked by this when you stick your finger, if you were to stick your finger in the socket. Not a good idea, because there's so much energy held by each electron. Each one is carrying 120 pretzels. They can hardly hold them. 120 joules. And that energy is what shocks you. Okay, current. Current. Now you could write down the current definition after you've done voltage. Current is the amount of electrons which pass the light bulb each second. Okay, so it's basically the speed. You could think of it as speed of the electrons. The amount of electrons which pass the light bulb each second. So here's our diagram for current. If I have a 1 amp current, what that means is I only had one of these guys pass in a second. But if you're moving faster, so fast that possibly 2 electrons can pass in a second. And if you have a 3 amp current, what that means is that in 1 second, you got 3 of these guys which passed. Right? So draw yourself those stick figures. Just say, that was 1 electron that passed in a second. These were 2 electrons that passed in a second. And 3 amps means 3 electrons pass in a second. What does it mean for brightness? If 3 electrons pass in a second, if you have a 3 amp current, it means that they all drop their own energy at the light bulb. So, a 3 amp current means 3 guys dropped energy at the light bulb, whereas 1 amp means 1 guy dropped energy at the light bulb. So 3 amps means basically it's brighter, because you had 3 different drops. 1 drop, 2 drop, 3 drops, instead of just 1 drop. So more energy is dropped here. For the 3 amp current, more energy is dropped at the light bulb because more electrons pass carrying their energy.